Hello. Welcome to APES AP review number 3. Number 3, I think, because we're one video ahead of our FRQ. So in this video, we're going to be covering soil, and based on what I've seen from College Board, I'm not going to go over like each thing individually. Instead, what I'm going to do is, because they've said both free responses are going to focus on, at least in some way, a problem and then your response, like a solution. We're going to talk about some of the problems that come with soil, and then some of the potential solutions. Okay. So we're going to I'm going to glide through everything real fast, and then we'll spend some time focusing on problems and then solutions. Okay. So there's a bunch of, like, in here, there's a lot of information about like soil, like, properties. And the only ones that you probably really should know are going to be, porosity, the measure of how much space there is within your soil, because the more porous soil is, the more water that can leak through it. And permeability, which is how fast water can flow through soil. And the reason why those two are the most important is because both of those have to deal with the water holding ability of the soil. Okay. And the water holding ability of the soil is really important because that affects your ability to grow food. Because if you have soil that can't hold water, then you have a desert. Okay. Think about it. The desert has a lot of sand. Sand are the biggest molecules. Sand does not hold water at all. So part of the reason why nothing grows in the desert is because there's no water there, and none of the dirt can hold any water. Okay. So those are the two most important ones. I would also say generally it's probably a good idea to know how to do the triangle. I don't think they'll give you the triangle. They would definitely give you the triangle under like normal circumstances, but on this test, I doubt they're going to give you the triangle. But just to put everyone's mind at ease, remember that you're looking at the way the numbers flow. Okay, so these numbers over here, these guys are all flowing sort of down. I guess they're flowing down this way, right? They're all flowing like that. Okay, so you're going to follow those numbers. These guys on this side are all going to be flowing this way. So you're going to be looking at those numbers. Okay, so if you get a soil sample that's, 30% clay and 50% sand, we're going to find where those two meet, which is right here. And that's how we have sandy clay loam, whatever the hell that is. Okay. So just know porosity and permeability. Okay. I'm not going to talk about soil horizons because you're not going to see them. But that kind of gets us to the first big problem, which is food security. Okay. Or more importantly, food insecurity. Okay. Referring to the number of people who either have poor nutrition or don't have access to food on a consistent basis. Okay. And so world hunger and food security is a huge problem because people don't have either enough food or the right kind of food. And that leads to vitamin deficiencies. We talked about a lot of these, iron deficiency with blood, vitamin A deficiency with blindness. That's a real big problem in rice countries, in countries that primarily eat rice. And then iodine deficiency, which is how you get thyroid diseases. Okay. And so these are probably the biggest problems these are the first big groups of problems. These are the problems that most people think of when they think about food, is people not having enough of it. Okay. But I think if you think back to this whole food unit, we also learned about probably the just as big problems, with food, in that for as much as there are people that don't have enough food, there's an equal problem of food waste and overproduction and inefficient management of food that we make. And so that kind of leads us into other problems of, there's the animal health issue of confined animal feeding organizations, CAFOs. That's just an inhumane thing. We've got the issue of there's a greenhouse and climate change issue with gas from beef. There's an inefficiency problem with beef that we've talked about. That, remember, especially in America, our primary food source is cows, is beef. In order to grow beef, they take a lot of food and water, and so most of the food that we grow doesn't go to us; it goes to cows. So we're inefficient with our food usage and what food we're growing. How we grow food is inefficient. Remember, we focus primarily on a monoculture, which is somewhere. We focus primarily on monocultures, which, if you remember, is just one. Here we go. That's a polyculture. That's plantation. There we go. Industrialized. These are monocultures where we're just growing one thing, right? We put a lot of resources and input into just growing a crop. Okay. And because we only grow a crop, that one crop that we grow in America just so happens to go to our animals and our cows and our chickens and our pork, because that's what we like. By God, we're Americans. You can't tell us not to stay inside. You can't tell us not to eat meat. So let's recap. So we've talked. So in terms of our issues with food, we've got world hunger and famine. We've got the moral issue of animal rights with how we grow our animal food. We've got an inefficient problem with most of our crops that we're growing are going to cows and not to us. So we're inefficient with our food and water resources. They might talk about the genetic modification problem, although that's not really a problem. And then there's one of erosion. Okay. Because monocultures tend to lead more to erosion because you don't have diversification. And then really that leads into the last one, which is a lack of biodiversity. And we've talked before about a problem with biodiversity because these monocultures, by definition, they don't have, you don't have biodiversity. You're only growing one crop. So you have a lack of biodiversity. So you got 5 different problems there that all stem from the current way that we grow food. So those are the problems. Now, why do those problems exist? Those problems exist because consumers like those things, right? We are inefficient with our food because people like beef and they want to eat beef. Okay, we're reducing biodiversity to grow these crops because people like these crops, right? Capitalism has deemed these crops to be the most important ones. So the issue is that the market and the powers that be are doing this because that's what the consumer wants them to do. Now, how do we fix these problems? Okay. Well, how we fix these problems, let's go one by one. So let's see. So we said, here, let me write them down. Let's do that. That'd be better. Okay. So in order, we have hunger. So we don't have enough food. We've got, we are inefficient. With our food. Well, let's just say we're inefficient with our resources. Okay. We have the moral dilemma. I don't know how to spell dilemma. That's not right. We'll just say it's a moral problem. Well, climate change is an issue, again, because of gas, but you don't have to know about climate change. Erosion. These are all written very terribly. Writing with a mouse is low-key hard, although writing for anything for me is difficult. And then let's also say pollution. Okay. All right, cool. So how do we fix these problems? Let's start with hunger. So the best way we can solve hunger is we grow more food, and there's a bunch of different ways. So in terms of solutions for how we can better solve world hunger, there's two things that you should say. The first thing is that we should be growing food more efficiently, which kind of solves the second issue. And in order to grow food more efficiently, that involves a couple things. Number one, we don't give all of our food to cows. Okay, if we turn around and start eating those foods, if we eat on a lower trophic level, that sort of fixes the inefficiency with our resources. What that also means is that we now have more food available to give to people that we aren't giving to cows. Some of the ways we could grow more food, we've talked about hydroponics and aquaponics before as a more efficient way of growing more food quickly. And if we're then turning around and we are the ones eating that food as opposed to giving it to cattle, that means there's more food available that's not going to cows. Okay. Remember, aquaponics is you're also growing fish with plants, so you're growing a meat source as well as a plant source, which is a good thing. If we switch to polycultures, so we have industrialized agriculture where you're just growing a single crop. If we switch to a polyculture where we're growing different kinds of crops. Where is it? If we switch to polycultures where we're growing a bunch of different kinds of crops and not just one thing, we're not just growing corn or rice or wheat. If we're growing multiple different kinds of food, that means we can actually produce more overall food, less of the one food that people want, or that we can exploit and make a ton of money on, but we get more overall food, which means there's more food available for people. Remember, we also talked about the iron deficiencies with hunger, or let's say nutrient deficiencies. And that's kind of where GMOs come in, because with GMOs, we can specifically create food that has those nutrients that people are lacking. The best example would be golden rice. A lot of people who eat rice were vitamin A deficient, so we created golden rice as a way to solve that vitamin A deficiency. Okay. Now, in terms of inefficient with our resources, that kind of comes to we just need to be eating lower on a lower trophic level, or switching from the source that we're eating to a different alternative meat source. We've talked about from switching from cows to chicken, or from cows to fish, or from cows to a smaller meat source. That's the main thing. Okay, so if they ask you about solution to our food problem, switching from beef to another meat source or from meat at all is a good idea, because cows are inefficient with their resources, and switching from cows to anything else is a good thing. The moral problem with CAFOs. So that's kind of a hard one. It's one that could be solved again just from switching from meat. Okay, but remember, the whole point of the CAFO is that it's part of the industrialized system. You're trying to grow as many of those things, as many pigs or chickens or cows or whatever, as quickly as possible with the least amount of work as quickly as possible. Okay, and these feeding operations are designed to grow the animal the quickest and the most amount of them with the least amount of work, right? So like one farmer can grow all these different chickens and manage them because they're confined in they're confined in a building. You don't have to move them around. You can feed them all the same thing. You can give them all the same drugs, and they're in and out within 5 months, Now, the problem with these things, aside from the moral thing of an animal rights issue, is that it creates an inferior product, right? The meat that you're raising here is lesser so than if it was free range or if it was organic, which is why those things cost more. But it creates the most amount of that thing as quickly as possible. So how do we solve that issue? Well, you could say if you could get people to switch to organic, okay? If we could subsidize organic and make organic cost less, because that's the main hurdle for organic foods, is that they're going to cost more. But if there was a way that the government could subsidize organic to make organic equal or less than the non-organic source, that would be a good thing overall for the health of the country. If you could convince farmers to switch to polyculture to not only to, again, grow more food, that means more profit for the farmer. And it also means switching off of these organizations, these operations, these confined animal operations, which eliminates your moral problem. And also remember that these operations are, to go back to our inefficient with our resources, they're not just bad for the animal. They're also inefficient with the energy for transporting and processing the food, as well as chopping down the crops to then turn around and give to those animals. Okay. Okay, let's talk about erosion. So the main problem with erosion kind of goes back to our monoculture, right? The more you grow one crop on a plot of land, the more of that soil nutrients and fertility gets lost. So if you're only meant to, it used to be that you could only plow a field maybe, once or twice, maybe 3 times a year. Now we're plowing those fields 6, 7, 8 times a year. And every time you plow a field, every time you grow a crop, those crops take nutrients out of the soil. And so in order to counterbalance that, we've had to use a ton of fertilizers to make up for that. But by doing so, when you lose soil fertility, it depletes the nutrients in the soil, which means you just have dirt. It's not dirt mixed with nitrogen and phosphate and potassium. It's just dirt. It's just rocks. Okay. And rocks that don't have any nutrients don't grow any plants. And remember, if there's no plants in the soil, that means there's nothing holding that soil in place, which can lead to erosion. It's what led to the Dust Bowl. It can lead to sand going into places where sand shouldn't be, dirt going into places where dirt shouldn't be, namely rivers and water sources, which now we have water pollution coming from erosion because you have dirt in your water source. So part of the issue here is a loss of soil fertility because we've just been plowing fields over and over again. And the more you plow a field, the more that field can be eroded, and the more water pollution that gets created. So how do we fix that problem? Well, there's a couple different ways you fix the problem. The easiest way would be don't plow 7 times or 8 times a year. Okay. The better solution is to try to minimize erosion as best as possible, and ironically, you do that with plants. So if you can use plants that you're not trying to profit off of as your soil protection, as your erosion protection, that would be a good way to control erosion. So here you've got these shelter belts, which were used during the Dust Bowl, where you basically just have a ring of trees that protect your crops from wind to keep your soil nutrients in one place. Contouring, terrace farming, strip cropping, where you have tall plants next to short plants, right? All of these are to protect the wind, so that even as you're reducing the fertility of your soil and making the soil easier to shift around, you're trying to protect it from the wind and the water to keep it all in one place and from blowing away by using other plants. Okay. Here you have alley cropping, where you're growing trees that act as a wind barrier along with shorter crops to minimize erosion. Okay. And then the last one is pollution. Okay. Now pollution can take many forms. So from an agricultural standpoint, there's both air and water pollution. There's water pollution from erosion. There's water pollution from the fertilizers and pesticides that you're having to put on these crops, on these monocultured crops, to grow them quickly and stop them from being eaten. There is pollution in the source of, in manufacturing and tearing down those crops. Where's my picture at? So you have to harvest those crops in some way, and a lot of times now it uses large machinery. That machinery runs on fossil fuels, so we're producing air pollution. The processing of an animal or of whatever the crop you're growing is consumes energy, which is a fossil fuel, electricity. The processing and transportation of those crops also use energy. Most of the crops that you grow, like most oranges in the United States, are grown in California and Florida. This is a fact. This is true. You can look this up. Most people do not live in Florida and California. So they have to ship those places. And in order to ship them places, you got to drive, and those trucks and planes and trains and all that stuff runs on fossil fuels. So there's an air pollution problem. So how do you solve the air pollution problem? Let's start with air pollution, then we'll go to water pollution. You solve the air pollution problem by switching this from having a source that you then ship out everywhere to local municipalities, meaning that if we could get more local farmers and get people to focus on local growing food more than, having all of our oranges come from one state and then shipping them out, we can reduce a lot of the transportation needs, which reduces our air pollution. If we switch from monocultures to polycultures, we increase our biodiversity. More plants means less air pollution, because remember, plants are a carbon sink. The more plants we have, the more carbon we can sink into it. And then lastly, how do we solve the water pollution problem? So there's two kinds of water pollution. There's erosion. There's three kinds of water pollution. There's erosion. Erosion and dirt. There are fertilizers and pesticides, because remember, no fertilizer and pesticide that you put on a plant stays on the plant. And then there's the problem with waterlogging, where you get salinization, where if a plant, the more water you put on plants, it causes those nutrients to push up, and that's how you get a gathering of salt, which kills your plants. So we have salt pollution too. The best ways that we can minimize our water pollution is, again, number one, you're trying to keep the nutrients in the soil as best as possible. So all of those ways that we talked about reducing erosion are actually good ways at reducing water pollution, because that keeps your dirt where it's supposed to be and not in your waterway. You could also talk about, with salinization, a more efficient way to water plants. A lot of ways use like air sprayers, and that's really inefficient because a lot of the water evaporates before it ever gets absorbed by the plant. And so using drip irrigation or ground irrigation, more efficient ways to irrigate means you have to use less water, and there's more of it going directly to the plant than there is evaporating into the air. Which means you're using less water overall, which means you eliminate your waterlogging problem. And then the fertilizer and pesticide issue, if we are able to switch from a monoculture to a polyculture, a lot of those issues solve themselves. So switching to a polyculture means you're not having to use pesticides because you have all different kinds of plants. So even if you lose 10% of your crop, you still got 90% that's still totally fine. And if we... the main issue with fertilizer is that fertilizer is putting back in the soil things that animals would put in there through manure and natural fertilizers. So if farmers were to switch back to just growing corn to growing all different kinds of crops and animals, they're now able to use the animals as a fertilizer for their soil, as opposed to having to go out and buy inorganic fertilizer. Okay, so all of these things are kind of connected. Making a polyculture fixes your pollution problem. It fixes your erosion problem. It makes you more efficient with your resources. But the main reason why people don't want to do it, and then farmers don't want to do it, is because consumers have said, we don't want a lot of different things. We want to eat Doritos. We want to eat meat. We want to eat cows. We want to eat packaged, processed bags of chips and crap that you buy in the middle of the grocery store, not the outside periphery of vegetables and fruits and meats and those kind of things. We want the processed crap. And the processed crap is made it makes the most money through monocultures, through fertilizers and pesticides, trying to make as much money as possible, and then baling. And so it's not, so the best way to solve these problems is through not being greedy by wanting, the one thing, but it's to diversify and increase your biodiversity, and better get a society that's more geared towards everybody being fed and not being fed with what they want. These are all the problems that come up through food, and we gave solutions to each one of them. Again, if you want to peruse this at your own leisure to kind of talk about, to kind of, do some more research on and go over again specific topics, I would highly recommend you do that. I'm not going to do it. And the reason why I'm not going to do it is because, like I said, based on what they've said, it sounds like they're going to try to diversify the questions a lot and focus more on problems and solutions. So that's why I tried to focus on that here. In the videos going forward, like next week is going to be resources. I'm probably going to do the same thing where we focus on solutions and problems more on like, topics of facts about natural gas. Because they're not going to ask you a lot of facts about individual resources because they just don't have enough time and enough questions. The only other thing that I would have you go over, or that I'll go over, is, you should know the nitrogen cycle, okay? Now, here's what I would know about the nitrogen cycle. I would say that in this test format, you don't need to know about the individual steps. Like, you don't need to know, to be able to define nitrogen fixation or assimilation or denitrification or any of that crap. But you should definitely know why the nitrogen cycle is important, okay? Because they might ask you, what is the point of fertilizer on soil? And the whole point of fertilizer is to complete the nitrogen cycle, right? Fertilizer has a lot of nitrogen in it, and that nitrogen is meant to replace and speed up the nitrogen cycle to increase the growth of plants. Because the more nitrogen you add, the more nitrogen that can be fixed into ammonia and that can then be assimilated by the plants to grow faster. So I would know the point of the nitrogen cycle. The point of the nitrogen cycle is to, number one, store nitrogen. Okay. Number two, it's to increase, it's to allow plants to grow faster and bigger, which means food is available. And definitely know how the nitrogen cycle can be disrupted. Okay. The biggest way the nitrogen is disrupted is through mass death or mass waste. Okay. So, humans produce a lot of waste. And if you add more waste to the soil than there should be, you're increasing the amount of nitrogen that gets put in here, which means that, nitrogen is sort of like, it's like anything. It can be a good thing for plants, but if there's too much of it, it can cause death. Okay. Water's a good thing. If you drink too much water, you're going to die. Food's a good thing. If you eat too much food, you're going to die. So nitrogen is a good thing for plants, but if there's too much nitrogen in the soil, it's going to cause plant death. So, the point of the nitrogen cycle is that nitrogen is held primarily in animals and plants. Most of the nitrogen in the planet is held as an animal or as a plant, or it's in the atmosphere. And if too much of that nitrogen gets put into the soil, whether it's through plant death or waste or decomposition or whatever, that means we have more of our nitrogen in the ground, and most of the nitrogen should be in the top half of this picture, not the bottom half. And the more nitrogen we put in the bottom half, the more it results in plant death. Okay? And that's how the nitrogen cycle gets disrupted. That's what I would know about the nitrogen cycle. You don't need to know, compare and contrast denitrification with nitrogen fixation or any of that crap. But you should definitely know how the nitrogen cycle gets disrupted and how it plays into growing food. Okay. But aside from that pretty much covers everything that you need to know about soil and food and what I think they'll ask you on the test. Like I said, this week you're going to be doing FRQ number 4. Next week, we're going to be talking about resources, both renewable and non-renewable, and we'll be doing FRQ number 5. Okay. I hope this was good. I hope you enjoyed it. I will see you next week.